While the risk meter gives a high-level view of the security of supply risk for the next few months, the system operator also publishes more detailed reports on our website. One of our most important graphs is the hydro risk curve graph. Let's see how this is built up and what it means. This line shows New Zealand's current hydro storage level measured in stored electrical power, or gigawatt hours. This line shows the mean hydro storage level. These curves indicate our chance of electricity shortage. Let's see how these curves are calculated. Current hydro storage level by itself doesn't have any predictive power. So how do we forecast future hydro storage? We do this using a complex model of today's power system. This model makes assumptions based on the factors we looked at earlier, as well as historical inflows and a whole bunch of assumptions around future events and behaviour. For example, imagine that after today it rained in exactly the same way for the rest of the year as it did in 1946. How would today's market use this rain, and what would the resulting hydro storage look like over the remainder of the year? Our model simulates this using the factors we discussed earlier. This mass of spaghetti lines shows this process for each recorded inflow sequence since records began in 1931. Let's look at how we use these simulations to derive the hydro risk curves. As you can see, at the current storage level, none of the simulations are falling below the red line. This means there is almost no risk of a power shortage over the next few months. However, if we move the storage level down, eventually we see some simulations fall below the zero line, indicating there is a risk of power shortage. When 1% of the simulations drop below zero, this represents a 1% risk of a power shortage. Repeating this process for each month of the year gives the risk curves their shape. Watch how the model recalculates the spaghetti lines as we drop down to the 4% and 10% risk curves. Now we have our hydro risk curves for the next few months. Let's use some examples to see how a change in the factors can affect them. If thermal generators increase their availability by reducing planned maintenance, this reduces the risk curves. What about a major unplanned outage? You can see how this causes a sharp rise in the risk curves. In this example, the outage is expected to last 3 months. Notice how the curves trend back to their original profile as we near the expected end of the outage. Remember, while System Operator publishes the hydro risk curves and input assumptions, market participants are free to manage any risks as they see fit. The System Operator also publishes information showing the HVDC transfer. The blue bars show energy sent north, and the orange bars show energy sent south. This can be a useful high-level view of market behaviour. Roughly speaking, the more energy sent south, the more storage is saved in our southern lakes. This is helpful in a dry year. We provide lots of information and graphs on our website that have a bearing on security of supply. This includes planned thermal generation availability, generation mix, and electricity demand. As we have seen, many non-hydro related factors influence the hydro risk curves. For this reason, we gather information from the various asset owners and market participants and use this data in our model to get as accurate a view as possible. As you can appreciate, up-to-date information about the factors we have covered is very important. The more reliable the information we have, the better our model and security of supply assessment. All of this allows the market to make informed and responsible decisions. It also supports the goal of providing reliable and efficient electricity to all New Zealanders. You can find out more on our website.